All right, the last section we're going to talk about here is 3D orderly problem solving, and this should be a quick one. So the first thing we want to look at is why do we care about problem solving? Okay, why do we care about problem solving? And your book talks about something called the creation mandate, and that is found in the book of Genesis in the Bible, okay? And in Genesis, specifically chapter 1, verse 28, it talks about us taking dominion. Okay, taking dominion. And that word dominion, if you look it up in a dictionary, it sounds very overbearing, like take control. Okay. And actually, that is not the implication of the text. In fact, rather than taking control, taking dominion means taking responsibility for. Okay. Taking responsibility for. Okay, so take responsibility for the earth. Okay, so we're taking dominion or taking responsibility for all the earth. That means we're going to take care of it and we're going to do our best to understand it. And, you know, as humans, we do our best, and sometimes we're good at things and sometimes we're not. But overall, we're gonna do our best to serve the creation that God has given to us. Okay, that He's asked us to take care of. And then part of that is being able to solve practical problems. And we've talked a little bit already about how chemistry can be used to solve practical problems to help people. And this section is about some specific steps for problem solving. But the first question I'm going to ask you is what is the extra step for problem solving? And that's this. I want you to write that question down. Let's say, what is the most essential step for problem solving? Okay, what is the essential step for problem solving? Or what is the essential step? And let's say, instead of problem solving, let's say for helping others. Okay. So when we talk about taking dominion, that's, you know, we're talking about the earth, and we're talking about other people as well. We're taking responsibility for helping other people as well. So what is the essential step for helping others? That goes back to what our whole theme is for the year. I'm going to say it's empathy. Okay, so the answer for that one is empathy. So write down that question and the answer, empathy. And I have an interesting quote to read to you. It says, let me see if I can type it so I can go fast here. A prerequisite for empathy is simply paying attention to the person in pain. And that's a quote by a man named Daniel Goleman. He is an author and a psychologist. He wrote a book called Emotional Intelligence. And a prerequisite for empathy is simply paying attention to the person in pain. And I think that's something that we can lose if we talk too much about problem solving. We forget that what the reason for solving problems is to begin with. And instead of being able to sit and sort of let people be in pain and listen to them, we just want to solve everything. That can be a problem also, because sometimes we won't actually hear the real problem unless we listen. So empathy is really about listening as well. All right, so now that we've got an idea of why we want to solve problems, let's talk about some specific steps that we will take as we solve problems. Okay, so the first thing we'll talk about is reading the problem. Okay, and you know, again, empathy comes back to when you're reading a problem. You know, in school, often we're talking about a word problem on a test. Okay, so it's literally use your brain to read the words on the page. But you can also take this to mean read, interpret the problem, meaning understand what the problem is. And in the real world, okay, as you're solving problems in your real life, okay, reading, we can also mean just listening, okay? So read or listen to understand what the real problem is. Okay, read or understand what the real problem is. And then organize that information, okay? Organize what you know and what you want. And I'll give you some examples later as we do some practice problems of how to organize what you know and what you want. That can be really key to doing well, is organizing what you know and what you want. All right, the next thing you'll do is think through what method will you use to solve this problem. And a lot of times in this class, the problems that I ask you to solve will already come with an explanation of the method, okay? So when you're thinking about methods, especially in school, and if it's a problem that I'm kind of guiding you towards an answer already, a lot of times I will use a verb. Okay, so look for a verb or action word that kind of directs you towards what it is you're supposed to be doing. So the method, how many, calculate, balance, all of those are methods, things that you'll do to solve a problem. Okay, so those are methods. The next thing we'll talk about is tools. So figuring out what kinds of tools you might need. Now sometimes those tools are like things in a laboratory, like a ruler or a balance or a graduated cylinder, but sometimes it's a formula, okay? And especially when you are using formulas, okay, you might have to look up constants, okay? So think about how are ideas related? How are ideas related? And think about constants you might need to look up. That's fine, okay? If you need to look up a constant, that's no big deal. That's a tool you can use in solving a problem. All right, and then once you know what you have, know what you want, know how you're going to solve it, that's sort of the nitty-gritty part. Hopefully, though, this is the easiest part, okay? Because once you've done the prep work, okay, this part should be easy, and that's the setup, estimating, and calculating. So set up your problem, write it clearly, especially if it's like a word problem with math. You know, and when you get to the end, before you do your final answer, kind of give a guess of what do you think this should be, and then calculate it and make sure that your estimate matches up with what you calculated it to be, and that'll really spare you a lot of heartache, okay? Because if you just assume your calculator is right all the time, you probably will be disappointed, because you know sometimes you just type things in wrong or you're not really sure, something happens. So make sure you estimate and then calculate and compare it. All right, and then the last thing I would say is one of the key things: check your answer for reasonableness. That's sort of part of estimating and calculating. And then make sure you format your answer properly, okay? All final answers should have a number and a unit. If you calculate density and you tell me the answer is 42.5, I'm going to say, no, that's wrong. Okay, the answer might be 42.5 grams per milliliter. Okay, but it's not just 42.5. All right, so my second question for you, I want you to write this question down, is how do you format your final answer? Okay, how do you format your final answer? Okay, and the answer to this question is you should format your final answer with the correct number of significant digits and a unit. All right, so how do you format your final answer for a word problem in chemistry? You give a number with correct number of significant digits and include a unit. So that's the answer. That's my second question for you in this video. All right, the last thing I'm going to do is do a couple problems. We're going to do a couple problems that involve density. All right, this idea of density is really important to us in chemistry. We're going to talk about that throughout the year. Density is not mass. It's not necessarily how heavy something is, but it has to do how much mass is in a given volume. Okay, so it's a mass divided by a volume. It's a fraction, and since it's a fraction, we can use it as a conversion factor. So I'm going to do two problems for you that illustrate this, and then we're done with chapter 3. Okay, so let's take a look at these problems that relate to density. And as I said before, the first step is to read the problem. So our problem here is a block of aluminum. Aluminum is the element that has the symbol Al. It's A with a lowercase l. And we have some aluminum that occupies a volume of 15.0 milliliters and has a mass of 40.5 grams, and the question is asking me, what is the density? Okay, and you'll notice I did some underlining and some circling, okay, and I like to do that to make sure I know what the problem is saying. So I'm going to write out what I've been given, and I have highlighted, or I've underlined what I've been given already in pink, so let me write that out. So I've been given volume, and the letter we use to represent volume in equations is a capital V. So volume is 15.0 milliliters. And mass, the letter we use for mass in equations is a lowercase m. So mass equals 40.5 grams. Don't get that confused with meters, okay, little m meters, but we use the same m there. And then what is it that we want to find? What is it we want to find? We want to find density, and we use the capital D to represent density. Now, what we need to know is that density, there's an equation for density, and we need to know that equation. That equation is density equals mass over volume. So using words, it looks like that, and then I can use my symbols, my lowercase m over my capital V. All right, so taking a look at what we're given and we want, it looks like we have exactly what we need. We have a volume we can plug in, and we have a mass. So let's do that. Density is equal to 40.5 grams divided by 15.0 milliliters. Okay, so there is my density. And so our final step is to put that in a calculator, and I'm going to put that in my calculator really quick. Sorry, I don't have one on screen to show you. So 40.5 divided by 15. My calculator gives me an answer of 2.7. Okay, but of course my calculator is not as smart as I am. So I need to think about that number, okay, and think about significant digits. All right, in terms of significant digits, I need to consider the fact that I'm dividing. Okay, and when I'm dividing, my answer should have the same number of significant digits as the number with the least significant digits. Okay, and looking at what I'm given, my 15.0 has 1, 2, 3 significant digits, and my mass has 1, 2, 3 significant digits. So my answer should also have 3 significant digits. Okay, also, so how do I turn 2.7 into 3 significant digits? Okay, well, I have to add a 0. Okay, that means we know more precisely that exactly that it's 2.70. It's right at 2.7. And then the final thing is we need units. So it's 2.7 grams per milliliter. The units do not cancel out. They both stay there. They get divided. So there's my final answer. I'm going to circle it. All right, this problem is a little bit different, so let's go ahead and read it. It says, what volume of silver metal will weigh exactly 2,500.0 grams? The density of silver is 10.5 grams per milliliter. All right, so going back to the beginning, what is it this problem is asking me for? It's what volume. So I'm going to circle volume there. And then what information have they given me? They've given me a mass here, 2,500.0 grams, and they've given me this information about the density. So note this is a little different than the problem we just saw. So, but I'm going to write it out the same way. Here I'm given a mass, which again, that's a lowercase m, is 2500.0 grams. I don't want to lose any of those zeros because that tells me something about the precision. And then we're also given this piece of information that the density is 10.5 grams per milliliter. And then over here, what is it that we want? We want volume. Well, I haven't given you any equations to memorize about volume, so and we don't know if this is a cube, we don't know if it's a sphere, we can't calculate the volume that way, but we do have that relationship that we just saw in the last problem, that density equals mass over volume. Okay, so if we want the volume, we can rearrange this equation to solve for the volume. So mathematically, okay, we can multiply both sides by v and divide both sides by d. Okay, and what's going to happen over here on the right side is the v's are going to cancel out. We're just left with a v on the left-hand side. All right, and the d's on this side are going to cancel out, and we're left with just an m over d on the right-hand side. All right, so we've rearranged that original equation, density equals mass over volume, into an equation that can solve for volume. Okay, so now all we have to do is plug it in. Volume is equal to mass divided by density, 10.5 grams per milliliter. Okay, so now I'm going to plug that into my calculator, 2500.0 divided by 10.5. And my calculator tells me that the answer is 238.0952381. And then in terms of units, let's look at what's happening here. There's a grams on top and a grams on bottom. Those cancel out. And then there's milliliters on the bottom of the bottom, which means they can get flipped to the top. So my final answer is in milliliters, which makes sense because milliliters is a unit of volume. Now we have one last task to do, and that is to look at significant digits. This number is way more precise than our original values, and that's not okay. But remember, we know that when we're doing division problems, okay, we want to look at how many significant digits our original information has. So looking up here at the top, there's a decimal point, okay, and remember zeros to the right of non-zeros after, if there's a decimal, are all significant. So the 2 and the 5 are significant and all 3 zeros. So that number has 5 significant digits. Down here, my density, the non-zeros are both significant, and then there's a 0 between non-zeros. So that's got 3 significant digits. All right, so my answer can only have as many significant digits as the number with the least. So that means 3. My final answer can only have 3 significant digits. So I count from the left, 1, 2, 3, put a little line there. And I look to the right. Is that number 5 or greater? No, it's not. So I don't round up, I just stick with 238, and then my units, milliliters. So my final answer is, what is the volume of the silver medal? It is 238 milliliters.